Hey, Happy New Year, guys, and welcome to a new episode.
Yeah.
Oh, yeah. So, we are ready for a new round. We've been gone for, I don't know, 3-4 weeks or something. So, that's good. And, well, just nothing much have happened in the last couple of weeks. Well, in Quarkus, at least. We've mined a few things. So, we've done Quarkus 110. 111 is in the works. The big news just before the break was the Rest Easy and Hibernate Reactive. We did a Rest Easy Reactive episode. I'll try and put a Hibernate Reactive up soon. But otherwise, yeah, things are churning along. Things are coming out. And yeah, it's ready for 2021. Yeah. What you guys
And don't take our mildly moderated tone as how 2021 is going to happen. It's just the start of the year.
It's going to be awesome, right? So no, it'll be fine.
It's just fine.
It's fine.
Yeah.
So yeah, Jason had this. He sent out
right.
He sent this email out about Quarkus is like a year in Quarkus, like a dog year. Like a lot of things happen in a year. So
yes, exactly.
Things can change.
So the way, yeah. It feels like a decade, to be honest.
It's been a long time. So anyway, we are kicking off the year
Actually, no. Let's talk about Quarkiverse again. So you know my fear is people don't quite get Quarkiverse. So let's go at it again. So you say Quarkiverse is growing, so that's good.
Yes.
That means we got more contributions coming up for the platform, right?
Well, not necessarily. So Quarkiverse is the word used for everything in Quarkus. And we have a thing called Quarkiverse Hub, which is this GitHub organization that we made to make it easier to make extensions. Because if we didn't have Quarkiverse Hub, you as a contributor that is not doing something Quarkus core would have to go set up a GitHub, set up publishing to Sonos Nexus and yada, yada, yada. And there's all these steps you have to go through. So we made this Quarkiverse Hub, which, let's say, automates or semi-automates all those stuff. And without having the core being depending on it. So it's trying to make sure that the core stuff can move forward and these extensions can move forward. And without having too much manual labor involved. So yes, Quarkiverse in the sense that there's a lot of stuff happening in Quarkus all the time. And then there's Quarkiverse Hub, which is this place to, hey, if you want to do an extensions, but you don't want to do all this maintenance stuff, unless the maintenance, what do we call scaffolding, we have that to make it easier for you.
And so then what's showing up on code.quarkus.io is orthogonal or will.
Yes. So that's one of the things that are going to happen in 2021 of good things is in 2020, the way things worked was that to be on Quarkus, you have to be in the Quarkus platform. And by the way, Quarkus platform is consisting of things that are both in Quarkus core and somewhere else, but it's like 98% Quarkus core repository and then a few outside. Well, depending how you look at it.
Yeah,
Camel is bigger than 2%. So Camel and Cogito are the two main ones who were not out, that was outside. So anyway, the problem is that the way Core Quarkus and all the tooling around it has been done so far is they rely on this notion of platform. And so what's happening, we already started working on it, and I just came back today, so I don't know if things happened the last 2 weeks. But the idea is to open up Quarkus and other tooling to, hey, there are extensions that can be coming from outside the platform that can show up. So that's coming. It's not
so the platform yet. To simplify a bit is where there is a BOM that drives the set of extension versions for a given platform, and then the tooling was using that as a discovery tool to say, let me help you with auto-completion and all of good stuff.
Yes.
And you want to also allow stuff that are outside of BOM to be visible.
Yes, basically. So think of this like npm registry, or Maven repository, or a Yum, what's the other one? Gem, like the same notion of having a catalog, that kind of things. So yeah, it's a more open box. But we want to do it in a way so we don't lose the ability to kind of at least be very sure that your combinations of extensions work. So there's some trade-offs that has been made. But
all right, sorry, I stole some minutes from the topic of the year, the first one at least.
Yeah, and that's actually
Hibernate Search,
which is one of the things you have an extension for, and it's in the platform.
Yes,
if I remember. So
yeah,
so that's good. So anyway,
the reality is that I've got a lava lamp right there, and Yoann has the lava lamp.
You have to have a lava lamp to be in Hibernate Search.
I can turn mine on, but it will take half an hour to.
Yeah, exactly. Might take at least an hour. It looks really weird and really nauseated looking until it really warms up.
Yeah.
So anyway, let's get started. So Yoann, it's the first time you're on Quarkus Insights, so maybe you can just do a quick introduction on who and what you are and how you ended up here, because I think it's all the man's fault, but you can.
How did I end up here? Well, I'm a software engineer at Red Hat. So I've been working in the Hibernate team for the past 5 years, mostly on Hibernate Search. So when Quarkus started, we jumped on the Quarkus bandwagon altogether, and Hibernate ORM was one of the first extensions we contributed, and then we started working on the others, Validator and now Search. So Search we've been working on the Search extension for a while now, but since Hibernate Search was in beta, we didn't advertise it too much. It was still in flux. And now it's here. Now it's in final.
Cool. And how do you get involved in Hibernate Search?
Hibernate Search, well, I was a user. More than 5 years ago, I was working in a software services company, and we were building business applications with Guillaume, and we were relying on Hibernate Search heavily for all our search forms and stuff like that. So we've been using it and contributing some patches, and when I joined Red Hat, I naturally was
you did more patches.
Yeah, well, I was doing more patches. That's for sure.
And was that a time where Emmanuel was the lead of Hibernate Search? I can't even remember.
It was Sane at the time.
Sane at the time, okay.
Yeah.
By the way, I love how it works. So you start a project, and then somebody takes the lead and replace half of the classes, and you don't understand your code base anymore. So I'm happy that it happened to Sane this time. So no, Yoann has replaced half of the interfaces and classes at least.
And I'm next, I guess.
Oh no, you have to stay. You only have 3 leads of the project, and then.
So what is it solving? So you said you were using it heavily. What was it solving?
At the time, well, the main point of Hibernate Search is to add full text search to your application. You have an application with your data inside a relational database, but SQL is great for all kinds of things. But when you're starting to want to do text search, it's a bit limited, at least the standard SQL. So if you want to find words, for example, in a text column, you can do a like my word %, and then you will find substrings. But first, it doesn't perform well at all because there's no index you can use for a thing like that. And you only find substrings. You cannot find words that way. So what about actual delimited words, like with a space before and after, to make sure that you cannot, you will not just find a match that happens to have your substring right in the middle of a word, but doesn't mean anything. What about ignoring plural or like trailing s's, ignoring gerunds like ing, stuff like that? When you request when your query is biking, you would like to find matches with documents that include bike. There are synonyms and stuff like that. So full text search is a real separate domain. There are separate concerns that are addressed by full text search engines, which are not traditionally addressed by relational databases. So Hibernate Search is a bridge between those two worlds, and how it works is that it's simply, well, it's simple to use, but it simply duplicates your data from your relational database into, in this case, Elasticsearch. So yeah, once this is done, and you can query Elasticsearch, get back the results, and Hibernate Search will help you to maintain this, to synchronize those two data stores, and to make the link between your hits in Elasticsearch and your managed entities in Hibernate ORM. So that's how it helps, and that's why it's useful.
I like I think the way I heard it described, maybe it was you, Emmanuel, saying that it was like if you try use Amazon search, this is the kind of same thing. Like it's easy to look products, and also you can find related things and that kind of thing. So
yeah, basically it can be used to implement something like that in your business application, where you just type the name of, well, a few keywords that are relating to the objects you're looking for, and you get a list of results. You can have faceting on the side with the number of match by t-shirt size and color and stuff like that. You can do geo search, for example. Search for
that are not too far from you.
Yeah.
Like less than, I don't know, 20 kilometers if you're confined somehow.
Yeah, for example.
Cool. So I know you had some demos prepared. Do you want to touch on those now, or do you want to wait until we talk about what Hibernate 6 is? Or
yeah, sure. Maybe it will make more sense what it really looks like, if you see what it really looks like.
Before that, Tokyo has an interesting question. So what is the real world use case for this? Usually an architect would advise to use Mongo Dynamic, I don't know, Dynamic, at the very beginning, if such search is required.
Well, maybe you will. Maybe you have a need for transactions, and you have a need for complex joins in your application. So it would be a bit. I mean, a relational database has use cases too. So if your use case involves your relational databases and you need a full text search, then using MongoDB will not solve the problem. And of course, you can already have a relational, an application based on a relational database, and you want to add full text search to that. And it's very easy to do that with a Hibernate Search. You maybe you don't want to move away from the relational database and the thousands of lines of code you already have, just to add full text search.
Or your team is more experienced in the existing technology and the new product. It's you don't have to move the whole stack just to add this complex search. So.
And while I haven't checked, I'm pretty sure that the full text search capabilities that Mongo has is definitely a subset of what Elasticsearch or Lucene would have, because these are dedicated tools for full text search, offering quite advanced stuff, like, as we were saying, category, what do you call that, faceting, more like these sort of queries. And
Hibernate Search, you guys tell me, because my understanding also with Hibernate Search is not only providing a way to do full text search, but also using some of the structure from the entities, the schema, so to speak, to be able to connect.
You're basically reusing your entity model and mapping it to a different data store.
Yeah, exactly.
All right, let's get coding, as Cesar says.
Show some demo.
Okay, so can you see my screen now?
Yes, you can. 2 seconds. Now we can.
Okay.
Hey,
so T-shirt, it's a T-shirt store. I have a T-shirt entity with each T-shirt has a name. I have a few variants of T-shirts, so with a different color, size, and a price for this combination of color and size. And each T-shirt is part of a collection in a certain year, certain seasons, and with a thematic for that collection that is summed up with a few keywords. So that's the data model we will work with. I can start the application without Hibernate Search, so you can see what it looks like. It's starting. And here I go. I have exactly what I was showing in the Java file, a T-shirt with a snowboard on it, available in blue and in various sizes. Part of the collection for winter 2019. And I have a bunch of these in my data store. Now, if I want to add a full text search to this, what I will need is first to add a few annotations to that T-shirt. So I had my base model, and now I will augment it. I just annotate my T-shirt as indexed, and then it would be enough, but if I only do that, I only have documents that include an ID, an identifier, so it's not very useful. In order to make it useful, I need to add data to my documents. So here I'm mapping the name property to a name field in my document. The thing is, the reason you have to map each property independently is that in the Elasticsearch world, configuration of fields is a bit more fine-grained. You have more options for each field. So you have the type, like in the SQL world, but you have a few options. You can decide that your field will be analyzed, which is the text processing that enables full text search. You can make a field sortable, not a full text field, but you can make a field projectable to be able to retrieve the data, because by default you may not want that. And if you don't want that, you can store the data more efficiently without taking so much space. So there are many options, but by default, the defaults will be fine here. Here you can map a field, but where it gets more interesting and where Hibernate Search gets more useful is you can embed other entities inside your document. So one thing to know when you're in the full text world, at least in Elasticsearch, is you don't have joins. When you have a T-shirt index, you will have only the T-shirt in it. If you want to query a T-shirt by its collection keywords, for example, you need to include the collection inside the T-shirt index. So you need to denormalize your data, and Hibernate Search will help you do that. When you embed the collection into the T-shirt, then the fields you add to your collection, the full text field keywords, will be available in the T-shirt index.
So just so I understand what you're saying, and I think this when you're saying denormalizing data, you're not saying about changing your existing data. You're saying the way that you're going to store this in your Elasticsearch is going to be denormalized, and that's what you search.
Yeah, exactly. So yeah, the relational database, of course, stays normalized, and it should be. And the copy of your data that you will put into Elasticsearch will be denormalized. So it's just a copy, so it's fine. And it will be kept in sync by Hibernate Search too, so that's fine too.
And so this actually relates to two questions. So one before, what's the difference between this and MongoDB? Is that, hey, you can get both the best of both worlds kind of thing, relational versus document-based approach. And then we actually got one here, which is a little bit where they're saying, what are the consistency guarantees with persistent to Elasticsearch?
It's eventual consistency. You will get eventual consistency. So yeah, the way it works is that after you commit after you commit succeeded, Hibernate Search will immediately send the document update to Elasticsearch. So that's what you get. You get post-commit updates to Elasticsearch.
Yeah. And that's, again, I don't want to harp on it, but I find that it's a very what's called intriguing benefit that, hey, the actual business data, the core one, can stay transactional, fully transactional, and this search thing, which is like a secondary business concern, is eventual consistency. Right? So you can mix up what matches your use case. So cool. Okay, go ahead.
So you need also a few properties that you need to fill in the Quarkus properties. So of course you need to tell us where to find your Elasticsearch cluster, which is Elasticsearch runs as separate in a separate JVM, and here we also need the Elasticsearch version, which is 7 in this case. The reason is that there are differences in the mapping capabilities of Elasticsearch depending on the version. The syntax is sometimes different, so we need to know that in advance. And here I'm in test mode, so I'm just dropping and recreating the indexes each time I start my application. And since I'm also testing, I'm using a synchronous automatic indexing. It means that when my transaction finishes and returns to the user control of the thread, I have a guarantee that everything is in Elasticsearch and is visible. Why you need to configure that is because Elasticsearch is a near real-time platform. By default, when you push something to Elasticsearch, it will take 1 second to show up in the search results, which is not very practical for tests. So I could remove it really here, but you would see that I have to wait a second after I make changes to see the results of my changes.
So where is the second happening? Is on the Hibernate Search side or on the Elasticsearch?
No, it's in Elasticsearch. That's a feature of Elasticsearch, this near real-time thing, and it's for performance.
So they switch the set of changes they want to apply to the index every second, essentially.
Yeah, they have a transaction log and they apply it every second.
Yeah. So so we had a question from Tokyo Walker here saying the thing happens in background application thread after commit to relational. I think so. Hibernate Search will commit to Elasticsearch in the same time as we commit to the transaction, I guess. But it can then be batched.
So the gathering the data from the entities right now in Hibernate Search 6.0, it's always done after the commit in the same thread. That part is always done in the same thread. Now, the part where you send the you send the information to Elasticsearch and you wait for the answer. That can be asynchronous. If I put async here, I will just push the data to a queue in the JVM, and the background thread will send the updates to Elasticsearch at some point in the future.
Okay.
So you got async, which is the JVM has a queue. You've got sync, which force Elasticsearch to not batch. Is there a third option then?
It can batch. It's just that we will wait for the batch to be done. In all cases,
before coming back. Okay, got it. Before saying I'm done with the operation.
Yeah. The reason is that, for example, if you have that's a problem you can have. If you have a test that updates your business data, and the line after you're doing a search to test that the search matches. Well, if you're not in sync mode, maybe it happens too fast, and you will search before the Elasticsearch has updated the data, and you will not find what you just pushed to Elasticsearch. Okay. So there are async, sync, and there's something more complex. There's read sync and write sync. So these are more advanced use cases. This has to do with the notion of commit in the Lucene backend. So it's not, this part is not really relevant here, but there's also the notion of refresh. Anyway, the default is fine for most applications. It's the default is safe and performant. So unless you have specific requirements, you shouldn't have to worry about that. So now that I have all that, I can start my application. Let me check. So I'll switch to my version of the application that has Hibernate Search in it. Oh, I didn't mention it, but I have an Elasticsearch cluster running locally with 2 nodes only, and PostgreSQL. So I started that beforehand. So it started. Here you can see that I mass indexed. So why is that? Hibernate Search will keep your data in sync as you change it, but if you have pre-existing data, you need to push all that bunch of data to Elasticsearch before you can start enjoying the automatic synchronization. That generally takes some time because there's a lot of data, but once it's done, you can go on and live with just the automatic synchronization.
So here it's because we're in dev mode that you initialize the mass indexing at startup?
Yeah. In a real world application, you would do the mass indexing upon deployment, on the first deployment of your application. But next time you start your application, you would not do that because there's a state in Elasticsearch, so it remembers what you index, of course. So now we launch the application, so we can see that if we query Elasticsearch, which is on this port, it created an index. It created a mapping inside this index with a bunch of properties that match what I requested, what I mapped using annotations. So I have the name, which is of type text with an English analyzer. I have variants, which are object fields with their own properties, color and size, but I don't have the price, which I did not map. I only have what I mapped explicitly. And that's important because if I was here to change the price of a variant, it does not affect the index. So Hibernate Search will not reindex a t-shirt if I just change the price. It's able to tell which changes are relevant or not. Now, I showed you mass indexing already, so that's fine. And maybe I should show you search here. So I have a search endpoint. I will search for bike, for example. I can see I have 5 hits total. It could be 5 millions. This is the number of hits I have, regardless of the page I'm currently in. Like you would see in Google 1 billion results, but it only shows the 10 first matching results. And here I have a match with biking, bike logo. So here it's case insensitive. It's handling the gerunds because I'm using stemming, which is a technique to remove these things and have approximate matches. I can see here that there's nothing matching. It's because I'm not showing everything. If I show the whole thing, you can see that, for example, this T-shirt is named Wheels, which does not match my query, but it is in the collection, in this collection, which has bike in the keywords. So I did a match on a T-shirt, even though the words that are matching are not in the T-shirt entity. They are in another entity, which is indexed embedded. So maybe you want to see the code that does that. I just have a T-shirt service with a few CRUD operations, and I added my Hibernate Search code. So here I'm using a search session, which is injected into the T-shirt service. The search session is basically the same as a Hibernate ORM session or an entity manager. It's just the entry point to what you want to do with the Hibernate search. I'm calling the search operation on the T-shirt class. So here I'm using the T-shirt class, but what I will query is the index that is mapped to the T-shirt class. I'm saying I'm adding some predicates. If my query is blank or null, I would just match all documents. If there is something, on the other hand, I will use a simple query string predicate. This simple query string is one type of predicate, but I have many other types of predicates, like a range predicate, a phrase, wildcard, and so on. But simple query string is a good start because it's a really simple syntax that you could even expose to end users with a +for end operator, pipe for or, and things like that. So it's really simple, not too specific to the full text world. So you can, that's a good start. And I'm targeting multiple fields with the same predicate. So I will try to find matches on the name field, on the collection keywords, the variant color, the variant size. Then once I add in my predicate, I'll just request that Hibernate Search fetches the results. So here I'm using paging. And this last line is just about DTO. So I'm just mapping my entity back to a DTO so that it can be serialized to JSON. So it's not specific to Hibernate Search.
So you're returning entities, as in managed entities, from a Hibernate point of view.
Yeah, the search result here returns T-shirts. And here, when I'm calling result.hits, I'm getting a list of T-shirts.
Okay.
But then I can do whatever I want with that. And in this case, I'm first loading my 10 T-shirts, for example, and I'm mapping those 10 T-shirts to a DTO. This is important because that way I can take advantage of batch loading, batch association loading. So, for example, those variants here are loaded all in the same query. So in the end, I think I have 3 SQL queries to load the data for these t-shirts, these 10 t-shirts.
Wait, so just is that Hibernate Search affecting that? So the
Hibernate
Search, based on your current Hibernate Search, it actually changes or set up the Hibernate query to return the right thing, or
Hibernate Search performs a query to Elasticsearch. It gets back a list of hits. In these hits, you have an ID, an identifier. Hibernate Search will map this identifier to the entity identifiers, and then perform a query to retrieve the t-shirts.
With a fetch plan that goes and get the right.
You could use a fetch plan, yeah. There are options for that, like loading, and then you.
I learned something. I wasn't actually aware that Hibernate Search was that's smart.
You can use an entity graph here. But I don't need that here, because just fetching the t-shirts with the lazy associations, and by setting here my fetch batch size, I will get my variant association. Well, it's an element collection, but it works the same way. I will get that lazy loaded, and these ones too.
Nice.
So, yeah, I think that's it. Now, if I wanted to, for example, add a new t-shirt.
By the way, you had one question I meant. There was one of you saying, will the data from import SQL be indexed on Elasticsearch too?
Well, that's what the mass indexer is for. If you add, if you make updates, if you initialize your database with a bunch of data, after that you have to load it into memory. Here I added an endpoint to my application that does just that. Typically, if you had an application like that with an import.sql, what you would do is that you start your application, it will push everything to your database, and then you call the reindex endpoint and execute this. This will execute, this will reindex all entities, all entities that extend objects, so all entities, and return when indexing is complete. So I can.
And I guess in a real app, you would chunk that up somehow, saying, "Hey, let's just take the stuff that's new since some date," or that kind of thing.
Well, you could do that, but then you cannot use the mass indexer. For the mass indexer, you can just you just have to tell Hibernate Search which entity has to be indexed, and it will reindex everything. But then you also have options to reindex manually just a subset of your entities. Generally, you don't need that, because Hibernate Search keeps your index in sync automatically.
Yeah, in case if you have like other apps going on to the same data and you don't have full control, I guess. But yeah. Sure. Cool. Go ahead.
Actually, just pop in the question by Eve.
Oh, got it. That's on there.
So does the pagination variable has to be hard-coded in your code, I guess? Why not either have it as a property or as query parameter?
Oh, you totally can. That's not a problem. Here I had coded it because it's simpler for me, but I have pages of 10 elements, but you can see it's just code here. So I could just have another page size parameter, and it would work.
You would add a config, forgot the name, config property.
Yeah.
The page size is from your property file and have it injected, or even be part of the query parameter. That's required.
And I see Sana put a comment here saying that in his experience, in a real app, you have the admin control, which still exposes operations such as schedule and index rebuild. Right. So you can in a real app you'll adjust these mass index and others. I guess it's to easy get started, easy testing. And
that's it.
Cool.
Well, you can see that here I just added some hack so that I reindex everything when I'm in dev mode or test mode.
Perfect.
Upon start. Yeah, so if I just insert a new entity here, so here you can see I added a new entity. It's a new T-shirt named "Jumping to the Stars" collection 4 with a variant size L, color blue. It's added, and if I search, it's automatically indexed, and it shows up in my search results. It's automatic. As long as you use the Hibernate ORM API to update or persist your entities, Hibernate Search will catch those updates and will trigger reindexing as necessary. Where it gets more interesting is that it also handles indirect updates. Like, let's say, for example, I want to search for a bicycle, and I want to find the T-shirts that include bikes. Here, I don't have any result. So I want to update my collection. I have a collection of T-shirts about bike and sport. It's a shame that I don't have any result when I look for bicycle, so I want to add the word bicycle to my collection. So I do just that, I update it, I add bicycle to my keywords. And then all of a sudden, my search with the word bicycle returns results. Because when I updated my collection, Hibernate Search caught that update, and it noticed that all the T-shirts of that collection had to be reindexed. It reindexed them all, and now I can search in the T-shirt index with updated data about the collection. So that's where using Hibernate Search becomes way easier than doing it yourself. Because when you only have one entity, you're not crossing the entity boundaries. Well, maybe you could handle just changing your repository and making sure that when the create or update operation is called, then you do the same update both in the database and in Elasticsearch. When you start having dependency between entities like that, it becomes way more complex, and it can get ugly real fast if you do it by hand.
Hibernate Search here becomes like an extra level indirection for you to do the mapping and searching, right?
Yeah.
So just because now you did this thing about bicycle and bike, where bicycle and bike is, they're different words, but they're also the same kind of thing. Does Hibernate Search or Elasticsearch allow you for searching for bike and gets result for bicycle?
Yeah.
Like
so
mapping of
that was a bit of a contrived example, because if you were doing full text search seriously, you would probably want to use synonyms. You can add as part of the analysis. I mentioned earlier that you configured an analyzer when you set a full text field. Here I'm using an English analyzer, but I can actually go further and configure my own analyzer. And one thing you can do when you configure your own analyzer is to add synonyms. You add a list of synonyms, a dictionary, basically, and that will lead Elasticsearch, when it has that list of synonyms, it will index bike as both bike and bicycle. So you can configure these analyzers within Elasticsearch, but you also have the option to do it within Hibernate Search itself. We have a nice DSL and API to do this configuration. I don't know if we have time to go over that.
Oh, no, it's okay to have the idea. So I'm just saying we have 15 minutes left or so. So there's one thing here I saw a comment on. Was it Philip, who says that it's funny? It's like, he said, great product prevents having to deploy complex distributed systems architectures like Kafka and Debian for both transactional and search use cases. So he's not, which I think is right. I just want to highlight to people that Hibernate Search is I don't know, how old is it? It's been around for a while.
Well, yeah, at least 10 years.
Yeah. So maybe it's, you have like 50 minutes left. Maybe it's time to talk about, like, you talk about this stuff is valid for Hibernate 6 and 5 and 4 all the way back. So what's the new in Hibernate 6? If you want to touch upon that.
A lot. So the point of Hibernate Search 6 is to move away from, well, not to move away, to change the APIs so that they work with both an embedded Lucene index and with a distributed remote Elasticsearch index. Traditionally, it was mostly about Lucene, and so the APIs were using Lucene classes everywhere, which was not which made implementing an Elasticsearch backend a bit hard, because we had to rely on some hacks. And it made, hacks like, for example, using a fake implementation of a Lucene class to hold native Elasticsearch data and pass it around in the APIs.
Just for those like me who can't remember, what's the relationship between Lucene and Elasticsearch?
Elasticsearch is using Lucene internally. Lucene is a Java library that implements full text search. Like, it manages, it allows you to write to indexes and to query the indexes. It's very low level though, so it's a bit hard to get proficient with Lucene, and Hibernate Search traditionally has made this much easier by exposing a much higher level layer.
Yeah.
And so Elasticsearch also uses Lucene, but it brings lots of things on top of Lucene. First and foremost, distribution. It's a distributed Lucene index, so that's a lot already.
For Hibernate, you could use Elasticsearch, but before Hibernate 6, right? It's just that you made it cleaner. Is that how I get it?
Yes, and so the API is much more adapted to Elasticsearch, and since it's more adapted, it allowed us to introduce more features. And for example, I have an example somewhere here where you can use the DSL like you always do. Use the Elasticsearch and extension. You continue writing your predicates like you usually do, and then right in the middle of it, you can write a part of your query, but only a part in JSON. So it allows you to take advantage of...
it means in the Elasticsearch way of doing things. So it specializes a bit of the query specifically to Elasticsearch. The rest is generic.
Okay. Yeah.
That's it.
So these like query hints, but well, not query.
Yeah, it's more than hints in this case.
Yeah, got it.
So you can use both the high level and the Java only Hibernate Search DSL and the native features of Elasticsearch, which is very useful actually, because Elasticsearch is huge. It has lots of features, and not all of them are available through Hibernate Search, of course. And you can go really very far if you have very specific needs. You can even transform the body of the request to Elasticsearch. So here I put a request transformer, and I just transform the JSON. I add a suggest property to my request, and later I can get back the response body to extract the parts that are not present in the search result, that are not made available by Hibernate Search.
And right now, this would look really nice once we have, was that Java 14, 15 text blocks, where you can bet the strings. Like, I'm just talking about the syntax in Java. But once you can do that, then this actually looks nice. Right now, it's a bit tricky, but cool. So that just make sure. So Hibernate Search is updated, clean APIs. It's more decoupled from the specific Lucene and Elasticsearch But
yeah,
at the same time, you can do both. But you can utilize more the Elasticsearch features in a better way.
Yeah, that's right. The base of the common part of the API is completely generic with no dependency to JSON or to Lucene, and then through extensions you can access the APIs that are specific to Lucene or to Elasticsearch, and so you can get as specific and as native as you want.
Yeah,
and that's it.
Okay.
That's yeah. And since we had to change the APIs, we took that opportunity to improve lots of things. Like we have bridges, which are a component that allow you to specify how a property of a certain type will be translated into Elasticsearch or Lucene data. Those bridges are much more powerful now in that they allow you to integrate into the dependency system of Hibernate Search. Remember this thing I mentioned, that Hibernate Search is aware of which changes are relevant and which are not. Well, in Hibernate Search 6, you can take advantage of that. You can write your own bridge that specifies which changes it's sensitive to, which is something you couldn't do in Search 5. So there are a bunch of changes also which were only possible because we had to break APIs, and if we broke APIs, well, we could improve the new design.
So just two questions here. So how big of a move is it? Is it like, we can just a little certain place you find, or is it like a...
You have to buy anything all over again. You have to buy everything all over again. Yeah, it's a whole different... It's a completely different API, of course, because there's no Lucene anymore. So that's... the concepts are pretty much the same. So it's more a matter of rewriting code and not of redesigning your application. But the API is completely different. You have an extensive migration guide, though, with a feature by feature feature by feature comparison between Search 5 and Search 6. And you also have a module that should help you migrate, that basically exposes Search 5 APIs to an application, but implements them using Hibernate Search 6. Okay. However, do not put that in production. It's intended as a help to migrate.
I'm sure someone will do that. So
that's useful. That's useful because when you look at a Hibernate Search part of your code, there is the mapping, which is one area, and then there is the actuals. Essentially, you got the mapping, maybe the mass indexing, and then the other big part is the set of queries, right? Yep. So you could start with changing the mapping to the new, slightly evolved mapping, when that happened, and then move to maybe your mass indexing, and then maybe move to search to queries one by one, essentially. So that's a not evolutive, but that it's not like a big, 1 million red arrows that you have to fix before hoping to run it, I guess.
Yeah, that's the idea. You just use this new migration helper. You fix everything that doesn't compile anymore, and then you can start migrating step by step.
And just, I should have checked this before, but was Hibernate 6, Search 6, how was that in context of Quarkus? When was that introduced in our API?
More than a year, I think, but it's been in preview mode, the preview status for as long as I can remember, from the start.
So what I'm saying is, if you've been using Quarkus, you've been using Hibernate Search 6 APIs since...
Yeah, it's always been Hibernate Search 6 because Quarkus needs to work in native mode, and native mode requires some changes in Hibernate Search. So we made some changes so that it works in native mode too.
Yeah, I've actually got that question here, like from Yoann. It's a relationship with the Elasticsearch client that's in Quarkus. And I'll add like a little comment to that, like what are the things that you had to do for Quarkus, if anything?
Yeah. So the Elasticsearch client in Quarkus is an integration of the official Elasticsearch client in published by Elastic. Hibernate Search uses this same client, so that's the relation. The Elasticsearch client, there are two of them actually. There's the low-level one and the high-level one. We use the low-level one because we have to work with many versions of Elasticsearch, and the high-level one only works with one version, the one that you specify in your dependency.
Okay.
So in Quarkus, you have the choice between Hibernate Search, the low-level Elasticsearch client, where you just send JSON. Basically, it's a thin layer on top of a REST client.
Yeah,
really.
so, which you would use if you were indexing something that was not in a Hibernate or stored.
Yeah,
thing,
and
else.
Well, you could use it, and you can also extract it from Hibernate Search. You have access to that client from Hibernate Search too, and you can also use the high-level client, but then you're really tied. You are coupling a lot with a specific version of Elasticsearch.
Sure. Okay.
There's one like question by Tokyo.
Yeah.
A tool like Symmetric DS can also be used for database replication and remove this overhead from the application. So yes, let's imagine Symmetric DS can store the data in, say, Postgres, and also store the data into Elasticsearch. That would do some of that work, but you will see very quickly that there is some mapping conversions happening between the objects that you will store in a database, or the rows, and what you really want to put in an index very quickly. So I don't know how much Symmetric DS is flexible that way to actually adjust your data. The other aspect is, so you store stuff in two different systems, but then how do you create those two systems and make it look like a single API? And that's the other stuff Hibernate Search brings to the table, is that you're just using the Hibernate API with just a full text search, extension for some of the APIs, but it's still manage object. You can still then update them and so on. So there is a integration from a app usage, a client usage, that you would not get in the Symmetric DS usage. But I imagine Symmetric DS is quite useful for quite a few other things.
Yeah. Okay, so Yoann, do you have anything else on the lab? Because we are running out of time. I have one question that I promised to answer, which is not related to Hibernate Search.
Yeah.
Are you good, or anything else you want to highlight?
No. Well, just try it, and that's about it. I think we've gone through a lot of features.
I learned a lot of things actually. So
code.quarkus.io, select the Hibernate Search extension.
Yeah, there's a
hibernate.org/search.
Yeah,
hibernate.org/search if you want to learn about Hibernate Search in general, and there's a Quarkus guide actually to add Hibernate Search to your Quarkus application, which is very quick to apply to your application. It's very simple, so you can try that.
Cool. And then Mimi very early on asked this more generic, bigger question. I'll have that one. It says, how do you see the future of Quarkus framework? Do you think it will take position like Spring framework? Very easy question to start 2021 off with. I can give my take on it. I said, Quarkus is, I think future Quarkus is very bright. And I see, as I said at the beginning, the Quarkus is moving and evolving and growing in a pace I couldn't even imagine. And for me, Quarkus is, yes, it has there's some, I'll say similarities between Spring Framework and Quarkus. But I think in Quarkus, we're trying to be a bit more focused on the container and performance, at least at the moment. So that's my answer. Yes, but no. Is that a good one?
Yeah, I don't think we really want to. Well, we're not really comparing at this stage. We're a bit moved away from like competition comparison and more like, okay, what value do we bring to the people writing applications in Quarkus? And I think I don't know how long has it been, but we've proved that we're not slowing down, and we keep having more and more features every release, and they happen almost every month. So that's the ecosystem you're buying in essentially with Quarkus, and we'll try to really listen to what people need from a set of APIs and feature point of view, while staying true to our cloud, container native, cloud native, focus. So if you want to write an application with Corba, you probably can do it with Quarkus, but it's not what the team is spending most of its energy on, let's say.
Corba, just for
Corba with a Q. Yeah, maybe there is something to it.
So, so I hope that, Mimi, it's a big question, and I think we did a roadmap kind of thing last year. I forgot how long back it was, like summer. And I think we'll have one Quarkus Insight where we might can go into a bit more details on this kind of thing. But I hope that answers your question, Mimi.
Quick question, Yoann. Your demo, is it available on GitHub somewhere?
Yeah.
I will push it in the next few minutes. Yeah, it's on the Hibernate demo repository of the Hibernate organization. You have a Hibernate Search
.com/Hibernate/Hibernate-demos.
Yeah,
something like that. Okay.
Yeah.
So if you share the GitHub URL, I'll tweet it out on Quarkus.io, and then
okay,
I'll put it on the show notes on this one. Cool.
All right, everyone.
Time's up. Well,
Thanks, Yoann.
Welcome to 21.
Thank you.
And we'll see you next week, which will be, I think, about Vodafone. The episode that didn't work last year, we'll do this time with the Vodafone guys from.
So a concrete user.
From they'll come on. And,
okay. Awesome.
Cool. Thank you, Yoann.
Nice.
Just
thank you.
Bye-bye.
Bye.